Hey class, this is Mr. Wagner with another quarantine video coming to you. Last night I had this dream where I was a muffler. I don't really get it, but when I woke up this morning I was exhausted. Anyway, with that, let's just jump into the math. So today we're going to be talking about surface area, which is another property of three-dimensional shapes. Last time I was with you, I talked about volume, but I kind of want to share surface area today with this box of mac and cheese that my son's been eating a lot of during this little quarantine. So surface area, as you guys know, area is just the space of flat space in 2 dimensions, and volume is 3-dimensional space. So if we wanted to have the volume of this, it would tell us how much macaroni was in here or how much it could hold in macaroni. But we also have to think about, there was someone who designed this packaging, and this packaging uses pretty much flat material, and so for that we're going to be thinking about surface area. And so there's these things in math called nets. I'm going to write that down here. A net. And a net in math is the flat rendering of a 3-dimensional object. So if I take this box that was a 3D mac and cheese box and I flatten it out, this flat surface of this 3-dimensional shape is the net of this prism. And as you can see, the rectangular prism had 6 sides, and when I fold it out into a net, you can see the 6 different sides. We have 1 here, 2, 3, 4, 5, and 6. And so if you wanted to find the surface area of this packaging and know how much cardboard was needed for it, you could just find the area of all the 6 different sides. And sometimes what people do is they will look at the net. Especially if you are someone who's designing 3-dimensional packaging, you would do your designs most likely in 2 dimensions and think about the amount of material that would be used there. And so this is what a net is. And I actually brought you a challenge today. Not only, I believe that you all could find the area of these different rectangles if I gave you the measurements of them, so I'm not going to waste your time with that. But I have a little challenge for you. There's another toy that my son's been playing with a lot, and it got me thinking about nets and how many different nets we could make for a cube. And so here's what I mean by that. Here's the toy. These are magnetic toys. So if we think about each one of these as being a 1x1 square, what net could I make that could fold up into a cube? And so I'm going to give you one here. And this is the first one. I can fold these up. And if I do this, I'll make a cube. And that net made a cube. I call that the T, right? So it started out as a T, and we made a cube out of it. Now some nets we can't make cubes out of. Now if I put this here, and I tried to put this all together, like this is not making a cube. It didn't work. And so my challenge to you, my puzzle to you all, is to come up with all of the ways that you can make a cube, all of the different nets. Now I'm going to give you a clue. There are 11. Mathematically, there are 11 different nets that you can use that will fold up into a cube. And if they fold up into a cube, it would be similar for any rectangular prism. But you might not have this toy at home, so you might want to cut out some paper or just draw it out. But I want you to think about, what are these 11 nets that will make a cube? And so that's my challenge to you. I actually just showed you 2 as this unfolded.